Click live. We are live, and we're waiting for Ramsbottom, Mr. Rams, to come on in. There he is. He's in the chat.
I'm guessing he's going to be 5 minutes late.
5 minutes, yeah, I guess. In a couple of minutes. A couple of minutes, that's fine.
Probably having get a cup of tea. Look.
Get the. I've got a brew. I'll get the. Let's see. Yeah, we are. Okay, so there is a call it a debate. Don't really know what to call any of these sort of things. There's a guy called Rams that wanted this proof for proof debate. I'm just sending some links out, so it will be on. I'll sort that out in a moment. Oh, is that it there? Yeah, there you go, look. So that is a debate on perpendicular, horizontal and vertical are perpendicular over distance. Proof for proof. Rams is a new guy in the scene, but he's not really new, and he's new to this bit that we're at the minute, where we are. I think he's following on from Mr. Slave type character. Most of you, I don't know whether people know about Mr. Slave. He was a travelling debater around some places. I've never actually been travelling to have a go at debating people myself. So we're waiting for Rams to come in. He will confirm. Proof for proof. So we're just waiting now. Normally, I've seen the modern day debates to keep everybody waiting, but we do it all live. See, all of the background stuff. A couple of minutes. He's clearing his throat, getting ready. Team talk. We will be back later at 8. This is only meant to take about an hour. I think that's all the time he's got. Sean G put in.
So what are you talking to this guy about?
Perpendicular, horizontal and vertical being perpendicular over distance.
Over distance?
Yes.
Does that change it then? Oh, sorry. Hold on.
Don't want to give anything away.
No.
Yeah, just a second. Bear with me. My daughter's school just called. So I'm just bringing her home, and then I'm going to set up and be ready.
Okay,
So maybe
no.
like 5-10 minutes.
Yeah, no,
That's
no
all right.
problem.
You can hear her in the background, and every so often you may hear some either My Little Pony or Cat in the Hat in the background. It's not me, I promise.
That's
Okay.
fine. It's okay. Whatever your music style, don't worry about it. We are accepting. We said to Blue Marble, we are
heard all
accepting of all sexualities, all sorts of different things. We don't really care. We are not scared or fearful of anybody. It is the internet.
Yeah, it's more just because I did say 1 o'clock. I'm just making my excuses early.
Yeah, no problem. So we'll just chat. It is the establishing horizontal and vertical perpendicularity over distance.
Yeah, so I've got no issue with the geometric side of things. So how you've defined horizontal and vertical is just if we establish a vertical using a plumb, is that going to be the same? Are they all parallel, like over distance?
Well, the horizontal, you mean? Well, I guess we can get into that. Should be interesting. And you've just a bit of your history. You were a traveling debater type thing. You've been on the internet doing this sort of thing for many years.
Yeah, discussing stuff like this. Yeah.
Okay.
Just, if you want, when I get set up, I had a good kind of description of the problem. I guess that I can cover like at the beginning.
Okay. Well, do you want to go first then? Do you want to lay out the problem that you think we have? And then we can go from there.
I have no issues going first with that, and then we can kind of get to a point of agreement. The main issue is that I'm getting a little bit out of breath trying to push a 5-year-old in a stroller, so you'll have to give me a moment to actually give you more than a few sentences.
That's fine. See, Gem Pandas was promoting us, so they come over here. That's debate flat earth and more. Have you ever done any of that? Have you ever debated flat earthers? There's plenty of servers set up for that, you know. I still contest that they've never had a debate over there at all, ever.
It's been all sorts of things. I think my very first debate was on like whether you can know anything for certain. I think that's the very first debate I've ever had, like 10 years, 20 years ago.
Wow. And what was that? Which side did you have to go on? I bet you went on that you can't, right? Just a guess.
Yeah, I did actually. I didn't have a choice because it was kind of forced upon me. Actually, no, I can no. I'm just find out. So
Is that me? Is that his mic going a bit?
Yeah, he's cutting out.
Yeah. They're asking in the chat. Ramshutu. Is that always been your name?
Pretty much. It comes from EverQuest originally. So that's like showing my age.
But so you were always that like 20 years ago when you started?
Not 20 years ago. I used other ones as well, but generally, yeah, more specifically in the last 10, 15.
Mm-hmm. So, because I don't think I've ever heard of you around here, but I mean, like, we haven't really been doing much debating.
Most of it was in North American servers. So you'd probably have noticed me on like North American discussion servers primarily.
Text or voice debate?
Mostly text originally, because never really had the ability to do a decent voice one that long ago.
Mm-hmm. We didn't do any 4chan debating, did you?
No, I completely avoided 4chan like the plague. Completely.
Why? Something
because I've never
artists.
seen a more wretched hive of scum and villainy.
What? You're not like the artists? So, where's the best place then for debate?
Well, right now, the one if you want voice debates, then that's Discord. If you want text debates, that's debateart.com. In my opinion.
Okay. So where in Discord then? Like, surely not here. Obviously, here on the level. The most interesting debates, right? I think so, anyway.
I guess there's interesting discussions. Debates I would classify as something slightly different because they're a little bit more structured. They're normally the way you use them to draw conclusions, you're arguing for one specific point towards a particular conclusion, you know, as opposed to just like a back and forward on an individual point and where you can go off in tangents and etc.
Yeah, that's why I contest that there's never been any actual debates on any of the servers, especially the ones related to flat Earth debate. Like, have you ever heard of Gem Panda's server called Debate Flat Earth and More?
No, I haven't. I mean, all I've done is like
you said 4chan was bad. You want to try that? You want to try over there, Gem Pandas?
Yeah. So most of the debates are kind of like formalized. So you've got the like the ones I'm used to are kind of like so many rounds of text that are so many letters limited. And then you've got so many days to post them. And then after that, you get people voting on who wins.
Yeah. Flat Earth Math. Have you ever heard of him? He's an old schooler. He says he's been around for a long time. So when you do debates on all sorts of different topics, is that because you're well learned in all of those topics, or is that just the art of debate? See, Mike's finished his construction of the LIGO replica. Hanford, obviously, not Livingston. You can tell. One's for you, Blue. That's not Blue. Look at the size of him. He's more globular than that. She put a thing on the door on the front of the house, Hanford. You have to put a ball under each bit as well. A couple of tangents. That's all it's missing. It'd be complete. Should we do a Buster song? How long have we got? Have we got enough for a chance for a Buster? People might want to listen to a Buster song. Let's see. But if I put a Buster on, I won't be able to hear it. I won't. It might be coming in soon. I'll do a quick dead straight lines. We should be back really quick.
Looking out on the shore, I found balance and so much more. It's getting clearer all the time. Always see all these dead straight lines and show me what's in reality. And I won't compromise between truth and lies. This is where I make my stand. Please don't take me to your la la land. It's all about geometry. Always seems so horizontally. Show me what's in reality, and I won't compromise between truth and lies. Show me what's in reality. And I won't compromise between the truth and lies.
Is that better? Can everybody hear me now?
Yes.
Reality is all
Okay,
I
for some
see.
reason it kind of messed up a little bit.
I don't need your fantasy.
Okay. Are you in? Are you ready? You're
Yeah, I think so. Okay, so I'm going to start off at the beginning. Okay, so
do you
the main
if you need to put anything anywhere, put it in the live chat. Are you going to need to show your screen or anything?
I'm not going to show my screen. I'm going to
Okay.
be super lazy with a few images that I kind of knocked up and whose production values show exactly how little effort I put in.
Okay, well, chuck them in
gonna be
the
the
live
limit.
chat if you do put anything in there.
Will do.
Okay, thank you.
Okay, so I'm going to start off with something like the beginning, I guess, is that I don't have any issue with the geometric proof and describing horizontals and verticals and perpendiculars and parallels and all of the deductive proof there. There's no issue with that whatsoever. You can do that deductive proof with geometry however you want. I have no particular axe to grind about it. I'm not really. I can just assume all of that deductive proof about here is your definition of vertical, here's your definition of horizontal. What does that mean? I've got no issue with that. So let's just assume everything with that deductive proof that is talking about purely verticals, horizontals. We could assume all of that's true in terms of the geometry.
The actual geometric proofs are proofs. They already stand as true.
Yeah, I'm just saying I completely agree with that. Horizontal and parallel, blah, blah, blah. So what you come with that, or what comes out of that, is you have a very strict definition of what horizontal and what perpendicular are. Sorry, not perpendicular, horizontal and vertical mean, what they are, what properties they have. That comes out of your the geometric proof. So when I say vertical, if I say something is vertical or two things are vertical, that requires those two things to be parallel. Okay, so that's fine, no issue with that. The issue becomes is if I have something in reality, so like a plumb bob, and say that plumb bob establishes a vertical, that makes statements about the properties of that plumb bob, because you've just gone and described all of the properties of vertical. If I call that plumb vertical, you've said that plumb has all of these properties. That's not the way we really do things in reality. You can't just call something vertical and assume it has all those properties. To call a plumb vertical, or that it establishes a vertical, or calling a level and say it establishes a horizontal, requires that level to have all of those properties. So you can't just say, well, we call horizontal level and we call plumb vertical. To establish it matches exactly the definitions that you've constructed from your geometric proof, you have to show that it has all of those. For example, take for example a paper airplane. I can define a plane as having an engine, having control surfaces, having a pilot. All those things are true. I have a paper airplane. It does not mean it has a pilot, control surfaces, and engines. It's really two contexts of definition. When I call a plumb vertical and a level horizontal, I'm not talking about your geometric definition. I'm just using a description that I know what that means in language to describe what those things are to you and me. So all I really have is level and plumb, and then I have vertical and horizontal, which are just words I use to describe it. Just because I call it horizontal or vertical does not necessarily mean that has all of the properties that you've ascribed to vertical and horizontal through your geometric proof. So we can call it plumb, we can call it level, but until you can show that plumb and level have exactly the properties you've defined in your geometric proof, you can't say they're horizontal and vertical. We can call them horizontal and vertical, but it does not mean they have those properties. Does that make sense?
Is that your argument that you? I'm trying to just get a grip on it.
This is the reason I wanted this debate. why I wanted to have this conversation.
That you
Because-
you don't go along with the definitions. Definitions are meaningless is basically what I heard.
No. So there are two concepts. What I'm saying basically is I've got no issue with geometric proof. I personally have no issue with people calling plumb and vertical horizontal. What I'm trying to say is that
Plumb's vertical.
I'll tell you,
I would particularly take
plumb
issue
is,
to people
plumb
calling.
is vertical, horizontal is level. So I've got no particular issue with those either, because those are just descriptions. But what there is there are two things. There's the description we give plumb as vertical, which is a description. We have the geometric proof that you provided on what vertical is, which is a definition of the properties of vertical. They are not the same context. So just because I or somebody or the dictionary says that plumb is vertical does not mean it has all those properties. And what I see quite regularly is the argument goes here, I've defined vertical and horizontal in a geometric sense to be all parallel and all perpendicular to the other type, you know, all of that stuff. That's not a problem. But then you say, well, plumbs are vertical, so they must have these properties. That bit's wrong. That bit's wrong because you're equivocating between the kind of the day-to-day usage of the word vertical. So when I say a plumb is vertical, it's like it just goes straight up. That's what I mean. It does not, that definition of vertical as we apply it to plumb is just language. It's a description. That's one context of the word vertical. The other context of the word vertical is the one you're using, which is the geometric definition.
Well, actually, I like perpendicular. That's a much nicer word, right? And that is anything hanging down by a straight line. Now that, to me, is the definition of a plumb. A plumb bob is a perpendicular, and that hangs down in a straight line. Now that just happens to be vertical.
No, it doesn't, because
Of course it does.
Just because your geometric description of vertical requires that a vertical must be parallel to every other vertical.
No.
I
don't say that. I just say vertical is hanging down. It's in a straight line, right? That's a straight line, vertical. Plumb bobs show you what vertical is in reality, right?
That is correct, yes.
Okay. Well, that's it. Like, I don't know why you seem to have a problem with a plumb bob being vertical.
I have no issue with calling a plumb bob vertical.
Mm-hmm.
The main issue is that your geometric proof, the proof that you're describing, like horizontals are horizontals are perpendicular to verticals, no issue.
Exactly.
All horizontals are parallel with every other horizontal.
Yeah.
That's, you need to show that level is horizontal. That's something that you
No, I don't know where you say level. All horizontals being parallel to the plane of the horizon shows that all horizontals are parallel to each other. I mean, everybody knows that.
That requires every single plane of the horizon at each location to also be parallel. So this is what you
slope.
do.
No slope. Horizontal is what you make
so
of the horizon, right?
This is the issue that you're adding. So the issue that the problem with your argument here is that you are.
Go on, pinpoint the problem for us.
Okay.
Because in case everybody doesn't know, right? I'll say, wait a minute, you don't know what the argument is. If everybody's listening, right? The argument is, if all horizontals are parallel to the plane of the horizon, right, then all horizontals will be parallel to each other. Now that geometric proof, you said you go along with.
Correct.
Okay,
let me clarify.
The only issue then is
that's the specific issue. So if you have that geometric proof, your plane of the horizon is one horizontal straight line that has specific properties in relation to everything else. So that's where you've added
it's a plane, isn't it? Not
so
not a
you've
straight
added
line.
a straight line that is the same everywhere. Now, when you say the plumb is vertical, you've established it's vertical, but now you've added an additional definition to what what vertical will require. It needs to be perpendicular to every plane of the horizon. Can you show plumbs do that?
Verticals,
if not,
well, they're defined as being perpendicular to the plane of the
Well, no,
horizon, yes.
But it's not defined. You've defined it like that. It's not that plumbs.
No, it's in the. It's in the.
Well, no, because your plane
do
of
you
the
want me to find
horizon.
you? I'll find you a
No,
definition if
the
you.
plane of the horizon that you're using is parallel everywhere. So there's nothing about plumbs that require the plane of the horizon to be parallel everywhere. You're just assuming it. That's
Parallel
where you
to
are injecting.
horizontals, which are all of the horizontals are parallel.
But that's your definition
And
of
actually,
horizontal.
all of the all horizontals will be parallel to each other, right? And also, all planes of the horizon would also be horizontal.
So what you're doing is you're injecting definitions and then requiring plumb to adhere to those definitions when you really you've made the assumption in those definitions. Now, where I'm saying I have no issue with the geometric argument is like if you want to talk
the plane
about
of the horizon being situated at right angles to the horizon, upright, vertical. It's not my definition. It is the definition of vertical.
That's one definition of vertical.
Do you have show us one that you? Because I think there's quite a few, right?
This is the issue here is all definitional. It's absolutely you're just manufacturing the properties that you want and then asserting that plumbs have those properties when they do not. And that's the thing. So the problem becomes where you're kind of injecting the horizontal and vertical, blah, 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 all of those things together. So let's just talk about, let's forget the words horizontal and vertical because we know you've got the geometric proof of, okay, I've got a horizontal, no.
Isn't that the debate?
Let me finish.
Let me finish. To show that they can be.
Yeah, so that's where I'm going now.
Oh, you're going to forget about them for a bit.
Yeah, so, but the thing is you have your horizontals, your verticals, and you've got your deductive proof about that has a specific definition of plane of the horizon, specific definition of horizontal and vertical that you attribute and you move and you make equivalent internally with your deductive reasoning. Again, no issues with the deductive reasoning. The issue is that all we have plumb and we have level. And the moment you start bringing in required definitions of what those things must be, that's where you start kind of tripping up your own argument.
Well, look,
so there's one here that says... Let me finish. So the issue with having a level is like there's no reason that a level in France must be parallel with a level in Canada.
I thought it was just horizontal and vertical being perpendicular.
No. Don't use horizontal and vertical. They are both just measurements of forces. The only thing that determines which directions horizontal and vertical which direction plumb and level are with relation to each other is how that force works. It's not a geometric thing, it's a force thing. So the moment they
are straight lines though, right?
Plumb and level.
No, vertical and horizontal.
They are orientations.
Vertical and horizontal are straight.
They are not straight lines. Plumb.
What?
Plumb is an orientation from which you can draw a straight line.
Vertical. Anything hanging down by a straight line, perpendicular.
Yes. The plumb is an orientation. Horizontal is an orientation. It's a relative orientation for the location that you measure it. There is nothing requiring that orientation to be the same in one location as another. You insert that requirement in your definitions by saying everything is parallel to one single plane of the horizon.
Are they perpendicular?
Yes.
In your world, right, that you're imagining now, are vertical and horizontal, are they perpendicular?
Again, I'm not going to use vertical and horizontal. I'm going to talk about things that we know we have in reality, the things that we can actually measure. So plumb and horizontal
you don't think we have vertical and horizontal in reality, do you not?
I think that the way you are using vertical and horizontal and the plane of the horizon is injecting a definition that doesn't exist in the real things that you are trying to
Which definition do you assume I'm injecting that doesn't exist? Please state it. Don't just say. Please state the definition that you assume I'm injecting that doesn't exist in reality. Please state it now.
So, if I have a level and it establishes, quote, a horizontal, you are saying that all horizontals are parallel, right?
All horizontals are parallel, yes.
Yes. So that's where you've injected the definition onto level. There is nothing requiring a level in one place, the line you draw from a level in one place being the same as the line, being parallel to the line you establish from level in another place. Your assumption that the definition of horizontal requires it to be parallel with every other horizontal, that's where you've now moved from your definition to try and establish to move your definition that exists only in your argument to reality.
Okay, well,
can we establish... Let me finish. What that means is that if you cannot show each level is parallel, or the line established from each level is not parallel to every other, you can't say it's horizontal because it doesn't match the definitions that you've given of horizontal.
Okay. So in order for us to establish proof for proof, the starting place for us to start with should obviously be horizontal. Because nobody's going to say you cannot establish a vertical, right? Because you can. You just get a plumb bob. That's a vertical. Right? Nobody's going to deny that a plumb bob is a vertical, are you? You're not going to deny that.
But that's one context and one definition of vertical, which is not the same as the other definition of vertical that you're using.
I'm talking about in reality, for us to be able to demonstrate a proof for vertical, you could just establish a plumb bob and say, look, this is a vertical. It is something that is hanging down by a straight line. Nobody would disagree with that, would they?
Because that is one contextual definition of vertical, and that's fine. Now, the geometric proof that you have that establishes a different set of parameters for what vertical means, that's something else. So if you switch between them, that says, oh, because I use this one context for vertical when with my plumb bob, that it now has all these other properties that I've assumed from my
what are all of the other properties that you think come with a straight line being called vertical?
When you say that all horizontals are parallel,
I've not got to the horizontals yet. Just wait. Wait. We are doing proof. We are doing proof for proof. So we start off with our Rams, please. We start off with the straight lines. Now, like I said, nobody's going to deny vertical. Can we get an agreement on vertical? Nobody has to prove vertical, do we? We are going proof for proof, starting at the beginning.
Why don't we just call it plumb then?
Because it is vertical.
But vertical is plumb.
It's a straight line.
So let's do this.
Vertical is a straight line that can be established in reality with a plumb bob, which is a perpendicle, anything hanging down by a straight line. Can we get an agreement on that?
I think we should just call that plumb. And the reason being is that you equivocate between the word vertical. So the reason you can make this argument is because you're injecting additional words that you would then change the meaning of in the middle of your argument.
I'm not changing the meaning, I'm just establishing vertical. For this argument's purposes, vertical will be established by a plumb bob, as in reality. We're going to associate that plumb, straight line, with something called vertical. That's it.
Okay, so in this case, let's be specific. So the word vertical here, what that means is plumb. it has the properties of plumb.
Straight.
Okay.
Hanging
So, okay,
down
it has-
in a straight line.
The only
The
properties
properties.
it has are the properties of plumb, right? It has no other properties. It is just a vertical lies in the direction that a plumb bob
It's
falls.
straight.
That's it. That's it. No other properties.
Straight.
So, okay. So
it's one of the defining properties of it is that it is hanging down by a straight line. That's what gives us the ability to associate it with vertical, because it is exactly the same as vertical.
Okay.
Okay.
So in this case,
we're all right with vertical being established.
Okay. No, I'm setting some ground rules for this. If you are defining vertical as a straight line established from a plumb bob,
I'm not defining it. It's already defined as that. Are you disagreeing with it? Please say that you're just disagreeing with it. Then we can get on to the next bit. This is a straight line called vertical. I've never heard anybody else disagree with this, apart from Rumpus having a go the other day. Have you had a word with Rumpus?
You're just talking over me. So the point here, the important point here is that we are establishing, for the purposes of this discussion, this proof for proof, logically, this is the definition of vertical. I agree. If you want to say that that vertical is a straight line orientated in the same direction as plumb at a point, whatever point you establish the plumb, I can go with that. But you can't then add properties to it that don't exist in plumb. So every time you add something to that definition about, well, like whatever you happen to add to it in the future. Vertical,
like I'm saying, vertical's already part of it. That's all we're doing. It's straight. It has the same geometric properties as a straight.
I gotcha. But what I'm saying is that you now have one definition. We have one definition of one definition of vertical that we've established from the plumb. You cannot add anything to it, because now you can't then say that plumb is vertical, right? So if I say
it is vertical, that's what we've just fucking agreed on.
Don't
take it away and then start putting it back again.
I'm
ridiculous.
I'm explaining what the conditions that would prevent that first definition from remaining true throughout the remainder.
Can we just establish this is a vertical straight line? I've never known anybody. You must be part of this group of people that have an aversion to straight.
I am more than happy to say that plumb is vertical. It's a straight line. The vertical is a straight line established from plumb. What I'm setting out is the boundaries to that definition. So if you start adding things to that definition later that says, well, vertical is now not just plumb, but also this other thing, that's when you say you have to go back to plumb. Well, if it's just
I'm not going to change it from anything else other than vertical, right? It's a straight line. It has the same geometric properties as a straight line because it's vertical and it's a straight line established by a plumb bob, in reality, by something hanging down by a straight line.
Perfect. So you would agree if you add properties to that definition later somehow without realizing it, then your argument that would be based on would be faulty, right?
Okay, right.
You'd agree with that.
Okay. So the next one then, right? The other one, since we're talking about the debate is vertical and horizontal being perpendicular, we'll do the other one, the horizontal, right? You can establish a horizontal being perpendicular, a straight line. That's establishable in reality, isn't it?
You can establish horizontal, we can call that the equivalent of level at a given point. It's the straight line established from a level at a point, right?
Right, but a straight line is established from 2 points, the extreme points of a straight line.
Yeah, but your level will be establishing the orientation of the straight line. It's not, level is not necessarily, you can't say level itself.
We're not talking about level, we're just talking about horizontal, right? Remember, for now, We're just establishing that a horizontal, a straight line, is available in reality.
From that, you're saying that, like, I'm just trying to, like, so you've said horizontal, you're saying a horizontal, you're defining it as perpendicular to a vertical.
It's just a
So
straight line.
vertical.
It's just a straight
Yeah,
line.
it's a straight line.
It's just a straight line, right? We'll worry about the perpendicularity later. Horizontal, in reality, is a straight line or a plane that can be established, right?
It depends on how you would establish it. I can't, from the definition you've given, I don't know if you can establish it. I'm probably going to agree that you can, but I just want to make sure that each stage.
I don't want you to be probably. This is why we're dealing with the proof for proof, right? So
how would you? So in that case, if you're saying you can establish a horizontal, how? You explain how.
In reality.
In reality.
In reality, right? There are many ways for establishing a horizontal in reality. They are done with a tool called a level, right? The tool, the implement that exists in reality is a tool called a level. And that tool establishes a horizontal plane of reference.
At a point, right? So at a particular location. So you have your level, where the level is, you can draw a straight line from that level, and the line that it makes is called horizontal, right? That's what you're saying a horizontal is.
Well,
so
a level, the tool, like an auto level, can be spun around 360 degrees. So that horizontal plane that is established would be the horizontal plane.
Yes, but that's established, that plane is established based upon the location and orientation of the auto level, right?
Well, the auto level is establishing the horizontal, yeah.
Yeah, but you can't tell whether if I have that auto level and you move a kilometer, 10 kilometers, 20 kilometers away.
Don't worry about that now. It would still establish a horizontal, though, right? That's all we're dealing with at the minute.
At a point.
No. The horizontal plane. Perhaps we might be better if we go to a water level. It's a different level, but it'll show you that it has two ends. This is the most geometric understanding of level, right? Now, each end of the water level in the tube, the water will find its own height, right? Equal heights at either end, and neither end will be neither higher nor lower than the other end. Right? Providing you haven't got bubbles in it, or you've stuck your finger over the end of it or whatever.
Yeah, but that is establishing a horizontal plane from the orientation of essentially the force vector on that water level at that point. So all you can say, like with an auto level, for example, you have a plumb or something that's measuring plumb, and the internal optics.
Keep it with the water level, right? Each point A, point B.
Yeah, so each side has, over the sum of the water level, you'll have forces acting on the water that are pulling it to the ground, and they form an equilibrium, and all that water level is showing. Yeah, exactly. Yeah, but it will be acting over the whole water level. What that water level is showing is the overall direction of that force, such that there is no shearing force on the water that moves it to one side or the other, because there's no component of the gravity vector that is along the water level in either direction. So it's establishing a horizontal plane at that location. It's not establishing a horizontal plane for every location, just where you have the water level set up, right?
Yeah, local to the water level, right? In between the two ends.
Local.
That's a horizontal plane, right?
Yeah. So the horizontal plane, you're establishing the orientation or the relative orientation of a horizontal plane based upon the specific location of the water level. Nowhere else.
You can't use a water level as a sighting tool, right? To look in the distance to see the level of anything like that, because that definitely would be ridiculous, wouldn't it? Because you're using the water level to establish a level in the location where the level is, right? You've got point A and point B.
Yeah, so all you can say if you use a water level or an auto level, is that you can establish a straight line plane of the horizon, but the orientation of that plane, the angle it makes to whatever, is based upon the level that you've measured at a location. Not necessarily that, like you said, not the same as a mile down the road, or not necessarily
It's
the
a
other
straight
side of the
line,
world.
right? It's the same sort of straight
it's a
line
plane.
as we have in geometry, right?
You can establish that horizontal plane with an orientation that's relative to a particular location,
With a water level.
or a regular level, a spirit level, or a auto level.
Yeah, because all levels establish a horizontal plane of reference.
All
Right, in
level,
the location that they are, right? Every level will always establish a horizontal plane of reference, and that horizontal plane of reference, wherever you are, whenever you're establishing it with a tool called a level, that horizontal plane will be parallel to the plane of the horizon, wherever you are. Anytime, guaranteed.
yes, I would get that as well. The plane of the horizon is going to be level at the same time, yeah. But what I'm trying to do is be specific about the definition. We've already dealt with vertical, what the definition of vertical is. We're now saying, so for the purposes of this debate, for the proof, the kind of the definitions that we are going to use for the remainder, a horizontal is a plane that can be established from a specific location with a specific orientation that can be derived at that location with a level, right? You would agree with that?
Yeah.
Sure.
Okay, right now, can you see my screen?
Yep, I can see it.
Okay, right. So you've got point A and point B. Right now, we've got a water level, and we can obviously put a water level at point A and point B. Right?
Yep.
Okay, so in order for us to have that, we already have a straight line, right? And we know that because of geometry, right?
So, sorry, you can put, are you talking about one water level at each point or a water level between the 2 points?
Yeah, one water level, one at A, right? And it stretches and it goes all the way to B. Now, point A and point B will be at an equal elevation, won't they?
Correct. It's so just to be clear, what this will do is it's establishing a straight line from the average gravity vector between those 2 points.
Right, well, yeah, it's a circle from point A to point B, right? Now, that's the geometric of point A and point B, right?
So what are we looking? So we got 2 points on the surface. Are we looking down
Just an
on those 2
equal
points?
elevation. I haven't had my chance. My missus is drawing me some water levels for the realizing Euclid, but this is sort of the idea of the concepts at the beginning, right? So you've got point A and point B.
Where is the surface?
Where's what surface? It's just point A and point B. That's the surface of the water at one end of the water level and at the other end of the water level.
Okay, so are we assuming I'm looking side on to these?
We're just having, yeah, if you want to, yeah. Side on, they're the same
so
elevation.
The circles that you've just drawn are circles of equal distance from the water level, right?
Yeah, we're assuming it's obviously a straight line from A to B.
Yep, okay.
Okay,
and then,
that's what that is. So that's a radius, right? That's a length, a distance. That's the shortest distance from A to B. And it just so happens to be an equal elevation too.
Sure, I think.
Okay, now, assuming this is a water level, then, you know, the Vesica Pisces and how to do the circles, right? And how Vesica Pisces work. Yeah?
I've not heard that phrase before.
Have you not?
This
Like eye shape in the middle. the thing that you're making that's eye shape.
Okay, yeah.
Right, that's called vesica Pisces. It's the intersection
sure,
of two circles about this
gotcha.
common radius.
Gotcha, yeah.
Okay, so with our original points A and B, we made those two circles and this vesica Pisces, and you make this other one. Right, so this C and D is perpendicular to A and B. And then we make another vesica Pisces, which makes this one here. Right? And then you can just keep doing this. Oh. So keep taking me circle off. From here to here. From here to here. And then you'll make two more.
Oh, okay. Is there a specific point that you're trying to get to here?
Right. This basically shows you that this point A and B being a straight line can extend the straight line because E and F are on the same straight line. This is a geometric proof of a straight line.
Okay, so why do you think E and F are equal elevations to A and B?
They're on the same straight line.
But yes, but point A and point B are both on the ground, right? You're making no assumptions about what shape the ground is.
No, they're in the air.
Okay, they're in the air.
Yeah.
So it's those 2 points are of equal elevation. How can you know that if you then moved A to F or B to F or B to one of those other ones, it will still show the same elevation?
Well, what you do is you get a water level, right, that goes from A to F, and you check whether point B is actually on the same one, don't you?
But if you do that, I'm assuming that will be like you walk a little bit on the ground, right? So let me just make sure I get this right. So you have point A.
Let me put some lines in for you, right? So just so you know, like this, seeing as we're talking about vertical and horizontal, those two lines there that you've just formed from your point A, the circles about point A, the straight line, made the vesica Pisces that made the perpendicular right in the center, right? It's perpendicular bisector. So if the A to B was considered horizontal, then this C to D would be called vertical because it's perpendicular to it. Now that relationship would be true, and you can keep going with these vesica Pisces to extend those straight lines.
Yeah, no, I get, but that's just, we've already established that a water level, you can establish a straight horizontal line with a water level
from A to B.
A point between the water points of the water level.
Yeah, point A and B. They were our starting points.
So you draw a line from A to B, and then we've already established that you can extend out that line infinitely far.
Absolutely.
What we haven't
just
established,
like this.
Yeah, that's just a big convoluted way of saying exactly what we were saying before. The issue and the thing that you haven't been able to show is that those points E and F, and as you continue, will remain equal elevation. Because if the ground is following a curve, they will be higher elevation.
Right. What if you arranged a water level and made like a center tap and have like 3? So if you have from point A to go to point B, and that be the center, and it carry on to point F.
But that would be assuming that A, B, C are all in a straight line with respect to each other.
A, B, C's up here, A, B, yeah. This is
so we could tell that a direct line between A and B with 2 points would be a straight line, because we can assume that's geometry. When you add a third point, the third point has to be on the straight line for that line to remain straight. So this is one of the examples I gave that you could use.
You could use this as like a proof to replicate this in reality?
Sure. So
Right.
you could have multiple points that you can see the water level over a distance, and they should all be straight if all levels are parallel. If they weren't all parallel, you would see differences in that shape of the water based upon the shape of the earth, the changing level, right?
Okay.
Yeah, that's what you would see if horizontals, the horizontals established from a level are not all parallel. They kind of deviate from each other. That would create, when you had your water level, if you placed your water level and it had multiple points
Yep.
all over the place, it would not follow a straight line if all horizontals are
I
not
think
parallel.
all the body of fluid will come to an equal elevation.
Correct, but elevation is just related to force, right?
Call it law of communicating vessels.
I would.
Have you heard of that?
I would call it potential, equal potential.
Have you heard of the law of communicating vessels?
I think I know what you mean. Yeah.
Okay, because it's like a law.
So, what's going to happen in your
Scientific law.
So, what's going to happen with your level if you had like multiple points on your level that you could establish whether it's a straight line or not? Because what the level is measuring is force, it's not a geometric measurement. It's not measuring is this thing straight, or it's measuring what the force is in these different locations.
So you did say that a water level establishes a horizontal between 2 points.
Between 2 points.
Yeah. So what about if there's like 3 points? Do you think adding a third one will make it horizontal between the end point and the center point, and then another horizontal from the center point to the end point? Or what about it just the two ends? Would that be the horizontal? Like, where are you imagining something different? Because I would say the center point obviously would lie on the straight line, wouldn't it? Like if you had two ends of a water level, right, A and B,
No,
and
I
then,
understand.
then you tapped in the center one, right? It would lie on that horizontal line, wouldn't it?
It depends whether all horizontals are parallel or not, which is what we're trying to establish.
The water level, like, wouldn't the water level establish the horizontal plane?
Only if you had a water level.
Have you ever used a water level?
Yes, I have. Can you let me finish, please?
Jolly good.
A water level will establish a straight line for 2 points. If you add a third point, you do not know whether it will establish a straight line, because the water level to be an equal elevation might be higher, might be lower. That's the point of this debate. That's what we're trying to know.
What about if you put that second point in the point where the third point would be? Would that not be the same?
You mean move point B to point F?
Yeah, like just keep point A wherever it is, right? Keep that as your big header tank, and then have another end of the tube, right? And go to B, go to F, go to E. You know, you could go to anywhere along that straight line, couldn't you? If it was establishing a horizontal plane, you could go anywhere.
If you're establishing the horizontal plane with 2 points.
Yep.
Okay, so you've got A and B, and you move B. Whether they are establishing the same horizontal or a parallel horizontal depends on whether all horizontals are parallel. That's the confusion.
All horizontals are parallel to each other.
And how do you know that?
Because all horizontals are parallel to the plane of the horizon.
And there we go. That's where you've just added a definition. So
I would suggest to you, right? It's okay you doing your little word games. Just show us a horizontal that isn't parallel to the plane of the horizon. Just present it.
Again, Plane of the horizon is the orientation of the horizon at a specific point. We went through this definition. This is where you're changing the definition on me. So
do you know what a
we started
plane
off-
is?
No. Let me finish.
Do you know
Please
what a
let me
plane
finish.
is?
Let me finish, please.
Because
So
a plane
you're
doesn't have
talking
a
over me.
point
Let me finish.
where it's a
Okay.
plane.
Okay, so this is where you just changed the definition.
I have
We
not
got to the-
changed any definitions of anything. This is where
Yes, I
you're
want to
playing a
explain
little bit of
exactly what you did.
wordsmithery.
No,
But
no.
go on.
No, let me explain. So we established and we agreed that the horizontal, what a horizontal is a straight line or plane
Yeah.
established from a position
Yep.
using a level.
Yep.
You've now changed that definition to say, oh well, all horizontals are parallel. Where did that come from? Where did
It come from the fact that you were moving the water level around and said you probably imagined some sort of a tilt. But I don't think that's possible, is it?
Conclusion. You're assuming you were in conclusion then, because we started with that definition of
We
horizontal.
started with a point A and point B, and we've given you a proof. You can have a look. It's on the screen. That's the straight line that we're talking about. So you know where E, A, B, and F, they're all on the same line. Now, if you have your water level at A and keep it at A and pick up B and walk to F, it will still be on the same straight horizontal plane.
But it might not be, because
What do you mean it might not be?
Because if there is a curve to the earth, if you moved point B to point F to actually be level, you'd have to lower from that straight line.
No,
so
you
that's
just
straight. No. So yes,
you wouldn't slope it, would you? You wouldn't call it a horizontal if it was sloping.
No, the horizontal is a straight line. Does that horizontal follow? If you moved your level, does the horizontal follow?
If you
where
move
your
from
level
B
is?
to F,
That's just, you're assuming your own conclusion, because
Well,
that's
how?
nothing in your definitions. Nothing in your definitions that we have established up until that point says that will happen. You've just said that if I establish,
Well, what if
if
we've
I
already,
establish,
what if
let
we've
me
already
just
done this
explain
test?
Let me explain the definition though here. So if you have no, let me explain what I mean by that.
Can I just get right? See, I'm clarify this, right? I'm saying if you have a water level and the level of the water is at point A, and also the other end of it is at point B, and also at the same level, right? That level being horizontal. If you leave A where it is and move to F, it will still be at the same level because that's a horizontal. Now, that's my position with a tool called a water level, establishing a horizontal plane of reference.
When you move to F, are you at the same elevation as point A?
On that straight line, yes, you're on the horizontal plane. Any
So
deviance from a horizontal plane will be an elevation change. So for you to deviate from that horizontal, therefore you are changing elevation.
So you are assuming that a straight horizontal line is also what we defined horizontal line as a minute ago is a straight line or plane established from a level. You are
zero slope.
Yeah, now. How do you know? How can you?
Because a horizontal has zero slope.
So you've added a new definition.
No, that's established with horizontal.
That's what you did. You just
horizontals don't slope.
But horizontal, the definition of horizontal is a straight line that you can establish from a given point.
Yeah. And it won't slope.
In addition to that, well, how do you know that a line that you establish from a horizontal doesn't slope?
Because the plane of the horizon doesn't slope. And all horizontals are parallel to the plane of the horizon with zero slope.
But the horizon is a horizontal that you're kind of establishing from your orientation at a given point too. So
with zero slope.
But you're assuming your own conclusion by assuming that a horizontal straight line maintains elevation. Nothing in your proof established that that's true. You've just said this is what it is. And yeah, if you say this is what it is, then sure, you can say that's what it is, but it
Yeah.
doesn't make plums do that in real life.
What do you mean? No, we're not. We're dealing with the horizontal and just
Well, yeah,
two
but, like-
ends of a water level.
Yeah, but like we know that doesn't happen in real life because when you go
What do you
to a
mean?
long enough distance, if we go to a long enough distance, the water level in between you and an object interferes with that object. So what you're really doing is this is exact. Yeah, you can see it. You can see objects behind water that are on top of water where
Behind
they
water. Sorry, I didn't. Behind? Please explain. What's behind water? What does that mean?
Yeah, here, there's like just perfect examples. Think of this as a water level that extends 10,000, or sorry, 10,000 meters
Can you
or
please
20,000
explain
meters.
behind water? It's not something I'm commonly understanding. I
So-
understand underwater and on the water,
So
but not
I-
behind water.
Can you see my images that I just shared? Can you see the images I just shared?
Well, I don't know. Where have you shared them? Is anyone else? I can't see it. Not in the live chat? There you go. No,
I think I did.
No, whatever's drawing them.
Yeah, I went to the chat button at the top here.
Oh, okay. Open chat. All right, okay. Let me just close this up. Let everyone see that. Yeah. Okay.
So you see those images, right?
Yeah.
So if you think of the lake or sea, the top one's a lake. I don't know about the second one. What you're seeing there is that Toronto is above the water level where Toronto is. Yeah, those windmills are on the water where those waters are. So what we're saying is that water level is now apparently above, or the water level at somewhere between us and the windmills is apparently above the level where the windmill is.
A hump.
Right? Exactly. Yeah. So the water is equal elevation, but isn't following a straight line.
Right. So is
all
that
the water's
higher?
under your feet.
Just a minute. So higher.
No, the same elevation. It's sea level.
Okay. So that bit in the middle, you assumes at the same elevation as the observer and what, the base of the windmills?
It's sea level, right? It's not gonna. Toronto in that image is like those towers, like 1,000 feet or huge elevation above the water, right? So the water isn't going to substantially change elevation. There's not going to be.
So there is a shortest straight line, right? This is where we were going at the beginning with the horizontal.
Well, what you have is if you trace a line that follows the top of the water towards Toronto or towards those windmills, it will not be straight if you keep a fixed level above the lake.
Okay, but is the shortest distance from A to B, is that horizontal?
Horizontal is a straight line or plane established from an orientation or a level at a particular point. So that will be a horizontal that extends out to infinity and will be a straight line. The C does not follow that line.
From A to B, right? We're imagining A to B now.
Well, no, because you can't. That would, if you put a water level on Toronto and a water level where you are at the lake, then you could make a straight line. It would go through the sea, but you could make a straight line.
Would that be from A to B?
Yeah, but it would go through the sea. It's going through the sea.
Okay.
Because you could tell, because a straight line from you to the base of Toronto is going through the sea, because you can't see it. The sea is obstructing it.
So that you'd say that the center point, which within the geometric thing that we just did, when we made perpendiculars, you'd say that there is a straight line going from A to B, and that would be perpendicular right at the point where the vertical would come down, and that would be perpendicular to vertical and be the straight line from A to B.
Sorry, where did put? I don't think so. And the reason being is that water levels are not giving you an orientation. They are giving you equal elevations between 2 points. So they can't tell whether the angle of plumb is different from one side to another. The same with level is that you can put level on one side of the lake and the other side of the lake, and they would both show level. That does not mean that the perpendicular verticals at each end are parallel with each other. That requires you to assume your conclusion, like you were doing with adding that additional property to the word horizontal that we had already established was one thing, that you now assumed it did extra things.
I didn't assume anything. We're just talking about the definitions. No, we were trying to talk about the definitions.
We started off with a definition, and you said you wouldn't add anything, and then we got halfway through the discussion, and you added a definition to the word horizontal. You did it. That's what you did.
Yeah.
Yeah, right. Have a look in the live chat here now. Can you see in the live chat? I've got if you want to add to it so you know what we're talking about. Oh, there's a big white line.
I know what you're talking about.
Right, so there's point A and point B. We're still talking about this geometric thing. And you've got a water level. Right? So you can use the water level as point A and point B to make a straight line. Now, right in the middle of those 2 points at those two ends, because you can use those 2 points to make a vesica Pisces, you're going to make a perpendicular to that straight line from A to B. Just by the fact that you have a straight line from A to B. The geometric properties occur, right? Without anybody putting an orientation to it. But you're using a water level. So you're using a tool that establishes a horizontal plane. So the assumption, I'd say, is on your half, your part, right? Whereas you're imagining that somehow this water level deviates from being that tool that establishes that horizontal.
Not at all. Look at I just shared a image. So the issue is that you are assuming things about that straight line. One of the things that you assumed is that a straight line horizontal will be equal elevation above the ground. That doesn't come from anywhere. There's nothing that you've observed, no measurement that you've given me that says that's the case.
That's not horizontal then.
Well, no, because we agreed that the definition of horizontal is a straight line that could be established from a level at one point. If you want to say, if you want to add
level from A to B.
Sorry?
We established that straight line with a water level and point A and point B. That's what we did. They're the points that we used to establish the straight line.
Is that straight line going to exactly mirror the surface of the Earth and elevation profile?
It's just the water level. The tool establishing the horizontal.
Yeah, but you're also adding definitions to that.
I'm not adding definitions to anything. You seem like you have a clouded mind.
You did earlier when you said like the deviation from the horizontal will be an elevation change. That is assuming that horizontal is all the same elevation.
No, that's assuming that you know how elevation changes are measured, because I do. Elevation changes are measured as a vertical change from the horizontal set by a tool called a level. That's how you measure elevation changes.
Yes, in terms of short distances, for sure, they're going to be about the same. But to say that level will continue to be level, like that's not
A water
something.
level.
Well, yeah. So the water level I just showed you in those images, that refutes that. That shows that doesn't happen.
What images?
The image of the windmills and the
The
images
tides
of
and the.
no, because it's the lake.
It
for
was in the
Ontario.
sea, right? Wasn't it?
You're not going to get tides on Lake Ontario that are like going to mask half of the city of Toronto. That's going to be hundreds of feet. It's like we just don't get that.
So what do you think it is? Do you think it's a hump of Lake Ontario?
What you're doing is you're saying that.
No, don't tell me what I'm doing. I'm saying when those pictures, are you assuming there's a hump in the middle of Lake Ontario that's blocking Toronto?
If you are saying that water level,
no, I'm asking you.
No. I'm using
your
argument.
pictures.
Well, no, you are saying that water level.
I'm not saying. I'm asking you. Are you assuming there's a hump in the middle of Lake Ontario?
I am using your arguments here. Okay, you said that a water level will find points of equal elevation. No, right? You're saying that's what it's.
Absolutely, yes.
Then
Establishing a horizontal plane of reference.
Using that argument, there has to be a hump because that water is clearly not at the same. They're clearly not at the same straight line, and we know it's all the same elevation. So there has to be a hump, and elevation does not follow a straight line. That's observable evidence, proof right there that trumps your definition of water level and horizon, because we know it's not true. Just that observation there proves it's not true.
Proves what?
It proves that the equal elevation does not follow a straight line. It can't.
When you say proof, you do understand what you're stating there. You will be able to back that up rather than just showing us a picture, right?
Yes. So
where's the proof then?
So the proof is fairly simple. If you had no hump, equal elevation, you are above the level of water. Toronto is above the level of water, and you will be able to see the bottom because all of that region is above the level of the water.
Then you'd be able to see the bottom.
You'd be able to see the bottom of the city of Toronto. However, what we are clearly seeing is that the water level is above the area of Toronto that you can't see. So the water level in the middle is, from the point of view of the observer looking at Toronto, is higher than the water level at Toronto. But we've established that water level. We've established that water level follows equal elevation. You've agreed that it follows equal elevation, which means that the only thing that can be happening there is that surface is curving. Proof.
With a hump.
Can't be anything
But
else.
it's all under your feet.
It's a hump. Sorry, Rob. This is the debate. This is a
Sorry.
hump.
It does not matter what you call it. What it's showing you. No,
you did. You called it higher.
All I am saying.
That was you.
All I am saying, all that this is showing.
All that you're saying is there's a hump in the middle. There has to be. Have you forgotten about the drop?
What I'm saying and what this shows is that if
you can't have a horizontal sloping upwards, can you?
Stop talking over me. I start talking, then you start going.
You've done nothing but talking. You've just said a load of bullshit, mate. You've just stated that there has to be a hump in the middle, yet you've forgotten that it's meant to be dropping away from horizontal. So now you're going to have to develop a horizontal that's sloping upwards. But everybody knows that there's no such thing as a sloping upwards horizontal. So what exactly are you going to do now? Where are you going to go?
So that's your argument, not mine. There's
not my argument.
Well, no, it's like what I'm saying, what I've explained. All. Just give me a second.
You're about to say goodbye to horizontal. Welcome to the new age. New modern science, mathematics. It has to be. It can't just be a simple straight line. Horizontal, traditional old school.
Okay, sorry about that. So what we have is we had our definition of horizontal and vertical that we established. We agreed that a water level
That they were
measures
straight
points of equal elevation. So
Yep.
what we can say is every point along that water is equal elevation.
Absolutely. A water level is a tool for establishing
Okay.
a horizontal plane of reference.
Okay, and what this image shows is that equal elevation, if you trace out the equal elevation, it can't be a straight line. Now, using words like drop, hump, whatever, doesn't matter. It really doesn't matter what we're describing.
Are you going to do an elevation profile for us? Give us an idea what an elevation profile would look like.
The water will be fixed elevation. It will be fixed elevation.
Yeah.
And we
So
can tell
do us an elevation profile then, so everyone can see what you're talking about when you're saying an equal elevation. Show us you understand what equal means mathematically.
Yes, it means the same number, right? But just because you have equal elevation, we can see that if you plot a physical line that follows equal elevation, from those images, you can tell it's curved. If I show you a elevation profile, which literally just measures distance with elevation, of course you'll get a straight line because it doesn't account for the change in orientation because level and the shape of the earth and distance itself is curved. So elevation profile, like, sure, it will give a straight line, but it's taking away all of the curvature that's inherent in the distance. It's dimensionless. It's just relative.
Right. I've got a few things that you might be able to. Have you heard of blue marble?
Yeah, I've heard of blue marble.
Okay, right. Check this out. This is one of his pictures. Can you see that in the live chat? Right, and then I'll get one of ours as well. So, blue marble took the water level thing from Wiki and added that bit in the middle. Is that what you're talking about?
Yeah, that's about it. Yep.
Okay, right. Now we have this one. Can you see that? It says level is horizontal.
Yes.
You see the way that the water levels are arranged? There's 3 separate water levels there.
Yeah, I can see that.
So the red ones are horizontal, obviously, independent. And then the green ones.
So what exactly do you think that shows?
It shows that the water levels are all at the same elevation, i.e. on a horizontal plane.
Or, well, what it's actually showing is that there is no discernible difference in the elevation at those different locations over, 2 meters? So you can't see a difference.
You could make that bigger though, right? Couldn't you?
Yeah, you could use an entire lake, in which case you see the dip. You see the change. So,
but you mean the change?
Sure. Like you see the change in the in where you can visibly see that the water level is changing from different locations because water level that you see in front of you is higher than the city behind it.
Right, but the actual water pressure is generated by the head of pressure that you have, right?
Which is dependent on the gravity vector, which we are still trying to show.
Vertical.
No, it's the gravity. It's which we still haven't established is parallel. So if the verticals are not all parallel with each other, then you could, and that's fine. There's no issue with that.
We're not talking about that. We're talking about.
I know, but I'm saying
all we're doing is establishing whether we can extend the perpendicular of horizontal and vertical over distance. And I'm not too sure about you, but I think you can definitely extend a vertical, right? I think you'd agree with that. You can extend the vertical up to the lights in the sky, couldn't you? Right, so that's definitely extendable in a straight line.
Horizontal as well. You can extend a horizontal straight line as well. Will it follow the shape of the Earth? No
What?
clue. That's an assumption to say it does.
No, a horizontal is just a straight line. I mean, how can it?
Exactly.
Because
Well,
you need the horizontal to
you said it does.
measure
You said
the
it does
shape
when you said,
and the change of the land, right? You have to
when you
reference it to
said-
something. The
when
horizontal.
when you said that deviation from horizontal, of that straight horizontal line established,
Yep.
is a change in elevation,
Elevation.
that's where you've assumed your conclusion. That's where you're
Right.
assuming
You
that.
don't.
part.
You use a level, right, to establish an equal elevation.
Correct.
Okay. Now that equal elevation is horizontal because levels
No,
are tools
no, no,
for
no,
establishing horizontal
no.
planes of reference.
No,
Yes.
that's
Yes,
that's
they
where
are.
you're assuming your own conclusion.
I'm not.
You are. No, I can explain. Let me show you.
Okay, well,
So,
tell me
yeah.
the difference between a level, the actual tool that establishes horizontals, and level and equal elevation. Tell me where they differ, please.
Okay, I can do that very, very
In your
succinctly
mind.
using the definition that you used. We agreed at the beginning. A water level, the horizontal it establishes is at a point. So it's the point between the ends of the water level. So that is a straight horizontal line, and you can tell that those two locations have equal elevation. Okay, so if you then move one end of the water level along, so you are now no longer at the same position. You're establishing a second horizontal, because remember, horizontal we agreed is defined as a horizontal plane established at a point. If you move your level, your water level, you're establishing a second horizontal with equal elevation. They don't need to be the same line. So if
you're keeping A at the same place, though, right, and you're moving B, are you saying that you would definitely develop two different lines? You wouldn't just extend the same straight line.
The observations we can make say yes, but like the point is that you can't assume.
What observations?
You can't assume that they are the same.
Have you done observations with water levels?
I've literally just shown you the two specific examples.
No, you've just shown us a picture of that you've got from somewhere, right?
Okay, so you were saying the picture's fake?
So I haven't got a clue. You've just shown us a picture. Surely you can't be using a picture as a proof when you're saying you're showing me a water level, which you haven't.
Okay,
you've shown us a picture.
So so what do you disagree with about the picture? What issue that we can go and dive in depth about that picture?
I have the issue with you
so
trying to understand whether the horizontal from A to B is the same if you move B a bit. Is it an extension of the same horizontal, or are you sloping it, tilting it from the original horizontal A to B just by moving B a bit? That's all I'm asking. Please.
If you move B, you cannot tell it's the same horizontal that you've established.
You
without
can
assuming
tell
that it is.
Right?
No, you would be assuming it because you've now established a level at a different point, or between two different points, and we've already agreed, and you've agreed that horizontal is defined as a straight plane or line established from a level at a point.
Yeah.
A different point, you cannot tell whether it's exactly the same level or not.
If you're starting off at the same point, if you have a similar point, right, there's no reason to assume that it would be a different line, is there? Surely.
Yes, there is, because the water level.
Do you doubt that the tool would be establishing a horizontal, or do you doubt what a horizontal is?
Because a water level is establishing a line at between 2 points, right? So it's establishing a horizontal, which is defined as a horizontal plane defined between 2 points.
You can see the thing, right? The 2 points. If we go back to the thing, we've already done it, right?
You can't assume that moving that moving one end of that will be the same line. You can't.
If it's a horizontal, if the tool, right, a water level, is a tool for establishing a horizontal plane of reference, then you could leave A at A and be assured that you could move to B, to F, to E, and anywhere along this line. providing the tube was long enough, and it would be a tool for establishing a horizontal plane of reference, because that's what water levels are, right? You can absolutely be assured of that. And if you doubt it, then I'd suggest you should attempt finding some way to present a test for you to prove that you, well, I don't know, what is it, lower? Or does it go higher? Is it possibly the middle bit gets higher? Is it that as you move further away, does the centre get higher? Or does it sort of drop away from what do you imagine occurs? Please. You might gone. Struggling to understand what you're talking about. You seem to be waffling.
I can't hear him.
I know.
I can hear you, Beth. No problem.
I think you're going to have to leave and come back, Rams. I think you're glowing green, but we can't hear you. I can't hear you.
How about that? How about that?
That's better.
Yeah. Okay. So I'm assuming you don't have you're just complaining that I'm waffling now by explaining exactly why the conceptual problem that you have. Because you went from no.
I'm trying to find out what your problem is. Do you imagine it goes higher in the centre, or do you imagine it drops from the other one? Because we've got numbers. We can go over them if you want to do that.
Well, it depends on how far away those 2 points are, because all you could establish with any measurement at short distance is a minimum precision of how those things differ.
Let's say 400. Let's say 400 meters.
Yeah, 400 meters. That will be not a very big change, right?
What do you mean? I don't know. Do you know? Not a very big change from horizontal, because horizontal is horizontal.
400 meters would be, in terms of the change, would be in the realm of arc seconds of deviation from parallel.
Water levels don't deal in arc seconds.
No.
They don't measure angles with water levels.
Well, you measure. You're establishing an orientation of a straight line. So that's
A and B.
A straight line between A and B.
Yes.
So the deviation between that and you move. So if you have that over 200 meters, let's say, and then you move one side another 200 meters, you've gone from 2 points that are separated by 200 meters, 2 points that are separated by 400. The difference in angle between those two straight lines.
Water levels don't establish angles. Why do you keep doing angles?
You've established a straight line, right?
Do you know any numbers? Do you know any numbers?
You've established a straight line.
I presume you've got a model.
Can you just let me finish? You have two straight lines.
You don't seem to know what you're talking about. I'm trying to help you.
Well, no, you're basically saying something that's nonsensical, indicating that you don't understand what I said. So I want to explain what I said.
Okay, so keep to point A and point B.
So it's a straight line, right? So you can draw that line on forever, right?
Yep.
That's okay. And you have another straight line that is you can keep drawing forever, right? So when you do point A to point C. So in my example, 200 and 400 meters. So you have two lines, AB and the second line, AC. They are two lines.
AF or AE, because AC is up in the air.
Oh, no, I'm not going to use your diagram.
Why not?
I'm not going to, because it's not the real world. I'm talking about...
Well, you can relate to it. You can say lower than that line, A to B, and put a different line on it so people can understand what you're doing. Because I can't follow you.
You should have no issue then if I describe the real world then. So I don't have to go back into your diagram.
Point A and point B. Imagine it's the real world with water levels at point A and point B, and we can relate that to a straight line. Right? Okay, now, let's keep that straight line there, and then imagine another line and relate it to the straight line that we've just established with the A and B. Right? Do that.
So we've got A and B, 200 meters. You walk with B, you walk 200 meters further away and put it down, and you establish a second line. That line also gets established infinitely far. If they are parallel, they will never meet, right? You'd agree with that?
Line.
Oh no, well no.
It's on the same plane.
That's what we're trying to establish.
Well, you can't have them parallel if they're straight lines, right? Then if they're the same
parallel,
plane.
I'm just trying to make sure we understand what parallel means. So, but that would be if you assume they're parallel. That's assuming your conclusion.
You can't assume they're parallel if they're on the same plane, because they will on the same plane. Well, they can never be parallel, so it would be ridiculous to assume they would be parallel, because they would be on the same plane or not on the same plane.
And this is what I'm trying to get at. So you have your water level.
So you wouldn't
straight
drop.
Line. Stop doing that. We have two water levels that we establish. We go 200 meters apart. We pick up B. We move 200 meters further down.
Yeah.
Okay. We know somehow, let's say we've got an altimeter or whatever, we know it's the same elevation. So you've got 3 equal points of elevation. Yeah. Right? Because you've got a water level and you can confirm it, whatever you want to do.
Absolutely.
And A to C forms another straight line. Okay. So at this point, without assuming your conclusion, you can't assume AC is the same as AB. So the deviation, because if they're parallel, those two lines will never meet.
They'll never be parallel. It'll either be on the same plane or the AC line will be below or above. It will never be parallel, because A is a common point to both lines.
Okay, so in that case, they'll be the same line. Okay, so I think that's like more semantics than anything else. Well,
it's not. We're just trying to be precise with our words, right? You're using geometric terms.
Okay, so let's say this. You start off with A and you B, you measure line, and you put them on a penny of the same height, and then you move B and you move it somewhere else. So those two lines you're saying would be parallel because separated by the thickness of the same
fucking straight line.
But the same straight line. You're saying it's the same.
If you don't move A...
Okay, this is getting... Okay.
I don't understand what you're trying to do. You're really struggling, obviously.
No. I think the issue is not me.
I think the issue is definitely you. Right? You've got a water level, and at A, it doesn't move. You don't move A. You're just moving B.
Yes.
Right.
So you have AB and AC, and you don't know whether they're the same line or different lines.
No, but we do know that A is common to both lines.
No, you don't. You do not know that.
Yes, we do, because A is definitely common to both lines. Line AB and AC. A is in both of them.
This is you're assuming your conclusion again. This is the whole thing that you're doing. If you assume that straight line from A to B extends to C, that's assuming your conclusion. We don't know that because C could be at the same elevation, but not in a straight line with A and B.
Yes, you're moving B to make a new place at AC. Now, A is common to both, right? You do understand that?
Yes, and you can have a line that joins with another line at the same location, but it doesn't mean they're the same line.
They could never be parallel.
Exactly. That's my point.
So it's impossible for them to be parallel because A is common to both lines. Do you not see that, right? The geometric thing is... So they can't be parallel. So don't start assuming that they possibly could be parallel.
You are literally just making this silly semantic argument.
No, it's just I know how water levels work.
No. What you're doing here is that I'm trying to present two possibilities with the water level. Number one, ABC forms a straight line. The other one is AB forms a straight line and AC forms a straight line and ABC is not straight. That's what I'm trying to establish here. Now, all of this is to go through this like silly objection that water levels don't, when I was talking about angles, water levels themselves establish a straight line. If they establish two straight lines that meet, there will be an intersection point between those two lines that will have an angle, right? That's basic geometry. If there is a deviation in plumb and therefore level, because level and plumb are basically perpendiculars to a force vector or aligned with a force vector, the deviation between those two lines, like how different they are from being the same line, based on that point of intersection, is going to be arc seconds. So putting it in perspective, like 30 arc seconds is the amount an hour hand will move in a second. So it's like, it's a tiny amount, a tiny deviation, but like, how are you going to be able to actually measure that with a 2 meter long water level?
Can you see my screen? Can you see my screen?
Yes.
Right, okay. Check this out.
So you've got 5 more minutes, by the way. And then I have to go. That's my hour and a half is up in a moment.
Okay, well. Right, so you've got point A. Right, now we've got another line here that we can put. You can have your point C, even though we've already got C on it. Now, can I put it, obviously, here when we're at B, right? We're at B, and it's that's the straight line from A to B. Now, we're going to move to C. Now, can I put C up here with a water level? Is there any chance that you, under your thing, that as we're walking away from B, can we go up here?
Not on the Earth, no.
Okay, right. So can we
go
go along this straight line and put it here? F?
No.
No, okay,
probably not.
So where would we have to go? Down here?
Down here, and the angle between the intersection of the line AB and that would be in the region of arc seconds. Okay, so smaller than that. Smaller than that.
Well, yeah. I don't know.
So closer to F. Closer to F. So much closer to F. So we need 1 arc second. Okay, like closer. 1 arc second. You want to get so close that the deviation is 1 arc second. So closer. That's still like 5 degrees. So that's like
all right. It's an angle, right?
But it's
I mean, like we can go over here, right?
Yeah, do that. Go all the way over there.
Right.
And,
okay.
Yeah, all the way over there.
I've actually got this sorted. Actually, delete that. Move that. You want to move that all the way over here, right?
Put it like 1 pixel close, and even then,
all
it's
right. This is GeoGebra, right? You can get ridiculous, but okay, there, right? You can zoom in, but you've got it lower, right? Rams has put the possibility of the water level in the distance being lower than this.
correct.
Okay.
Same elevation.
But no, not higher, lower.
Typically because the change in plumb is always positive. So the Earth is curved downwards instead of convex the other way, you know. So it will be down. Everything will be down.
Always down. So if we were to go from a water level at point B back in the opposite direction towards A, would that be like below as well? If we go from this side of the water level, because originally we had point A and point B, but now you've like moved it over there and it's gone down a bit, hasn't it? So like if we had our original point A and point B, would that still be there? That would be higher, would it?
No, because you've moved point B there. That would be the original line again.
No, but point B would have been here, though, right?
Point B is where you put the water level originally. When this second line, the line that's lower, is because you moved point B all the way back. Right, if you moved it back to the beginning, it will still be that same straight line. That you had
so it
originally.
Would be here, though, right? Would be higher.
It would be lower. It would be on the original straight line.
Right, so if I bring this one here over to A, would that eventually get higher than point A? Because it's on the same level at the minute.
It'll be on the same.
It's not lower there, is it?
A and B is a straight line, so it'll be the same both ways round. It's only if you then move point A, or like to mirror what you did with point B, that it will be lower.
Right, so it would go lower. If I were to move point A now, it would get lower. So there is a point here where it's highest, right? If I were to move point A here and point B here, it would be higher than the original point that's on the straight line that we made for the perpendicular. Because this AB was the original straight line that we used geometrically. Have you just put a hump in the middle?
Like in that diagram, it would be incredibly small.
Well, I don't know. It's a straight line. I mean, you could make this 400 meters, couldn't you, from A to B?
You could, and it would be an incredibly small, like to the point where at that short distance, the amount of error that you would have in your measurements, like so the ability to measure it accurately would be dwarfing the actual difference.
You can measure with a ruler, though, right? Have you seen people measuring with rulers?
Yes, but like,
okay,
what accuracy do you think a ruler has?
Like, well, could you measure 3.1 millimeters with a ruler?
Sure. Is that going to be? Is that middle bit going to be 3 millimeters higher?
I doubt it, but some people might say it might be.
And I don't know what, without doing the calculations, I'm not entirely sure. But like the angle.
I would have done some calculations.
Look at this
So
way.
you're saying that you expect there may be a case where you can have over a 400 meter water level that in the center there's 3.1 millimeters higher than the straight line established from A to B?
But how would you even measure 3.1 millimeters at 400 meters?
With a ruler.
You can't, because then it's a comparative, it's a relative measurement, right? So you are trying to tell the deviation from a straight line. So you would need the straight line, and you would need to be able to make that straight line accurate enough so that the overall error doesn't sum to more than 3.1 millimeters over 400 meters, which you said yourself that you can't measure 1 arc second accuracy with, say, an auto level at 500 meters.
Absolutely,
so
yeah.
That's 2.1.
Anybody who's saying that you can, they're lying.
Yeah, no, I would likely agree with that. I think most of the reciprocal zenith angle measurements were made with a laser locking robotic total station, though, which is a completely different device. You know how they work on principle. They use laser reflection off a prism to get you a super accurate lock that can be one.
I think most of the ones that you hear about are done with a T2 and a T3. I think Larry's been telling everyone about the tools he used. I think it was Jesse that used the total station. Larry uses old school. It's proper old school.
The main surveyor
that you've heard about.
The main surveyor, which I'm assuming is Larry, in all of his videos where he's measuring reciprocal zenith angles.
No, the main surveyor's done a Jesse Kozlowski. Jeff, he's not around anymore, unfortunately.
So he was the one
shout out Doofus.
Yeah. So yeah. Anyway, I've got to go. You've got the time here.
Okay.
But yeah. So in summary, all of this, as I kind of explained, you're assuming your own conclusion. You're kind of going through and then you're adding these definitions to your definition of horizontal and vertical halfway through. And then when you do that, you kind of then say, aha, well, level is this and vertical is this and horizontal is this. Because
I don't exactly do that. That's not what I've done. I think everybody can see that that's not what I've done.
Like, I called you out when it happened like twice. So yes, that is exactly what you're doing. That's why you can come to the conclusions you are. Okay. Anyway,
what
thank you
conclusions
so much
have I come to? We didn't get past the proofs of horizontal and vertical being perpendicular.
Your assumption that verticals are all parallel on the real world.
That's definitely not my assumption. That's you that's just stated that many times.
Okay,
you won't find anywhere that I've said that. So other than you saying that I assume it, which
okay, if
that's
you're
on
agreeing-
you
if
completely.
If you are agreeing that verticals are not all parallel with each other, then I can go home. That's exactly what I'm arguing. They're not all parallel to each other. So if that's not your position, then
That's
I
what
will.
you,
I would
that's what you
accept-
were arguing, really. Really, it's a bit
No.
cheap to just state it at the end, isn't it, and claim victory
I've
when
been
that
saying
wasn't
it all
anything
the way
you
through.
mentioned all
I've
the
been
way through.
saying
No, I
it
don't think
all
you
the way
did.
through. Yes, it
That
have,
was
my
your
God.
argument. We were talking about perpendicularity of horizontal and vertical,
But
and that being extended.
which is part of like exactly how you've defined that. Like it's right there. It is right there in your like hourly span where it says all verticals are parallel. You're
It doesn't
saying
say that.
plums are vertical.
It does not say that. Can please state where it says that?
Let me find.
We will be going live. You do realise this was about vertical and horizontal being perpendicular, right? As far as I can see, you didn't have a horizontal plane to have all perpendiculars being parallel to. I don't think you can have that horizontal plane. That seemed to be the problem. Me saying that a water level establishes a horizontal plane, and you saying, nuh-uh. So we can do the geometry thing. We haven't even started with any logical arguments. Oh, is he gone? No. Are you looking for is it in the bot? You're assuming.
Yeah, it's in the bot. I'm just trying to scroll back and find.
You've not grabbed the nth meme, have you? Yeah, Jesse's total station. Nice one, Science. He can't bring up his Lake Ontario hump, Barry. Doesn't know what it is. None of them do. It's a vertical rise, but he's after a drop from horizontal, because that's what Great Shadow Giant Jesse has said. The horizontal paradox, right? It's a blue marble induced horizontal paradox. That horizontal paradox being that you can't have... Go on, point to the bit that you're offended at the most.
But all perpendiculars to a horizontal plane will be parallel, and you're saying vertical and horizontal are perpendicular.
Absolutely.
So there you're assuming verticals are all parallel with each other.
Oh, whoa, don't be using deductive logic like that. It's not been stated, is it? Right? Look, there's all geometric truths. Which one do you disagree with?
Well, I think like I said right at the beginning, I don't object to the geometric proof. I object to when you start moving that to the real world.
No, which
requires...
one of these do you object to then?
Well, in the real world, well, when you say verticals are plumb, that requires that all verticals are parallel to all others.
Blue marble. No, Blue Marble Science said that. right? I think most
That's-
people would agree to
that's-
that. Verticals are plumb.
No, the second bit, that because you're saying verticals are plumb, you've now
Vertical is a
equivocated.
straight line as well.
You've
Are
equivocated.
you all right with that?
Stop talking over me. I have to go. I just want to get this out.
Yeah.
You've equivocated. You started off with the one definition. You started off with the one definition of vertical, and then as we progressed, you then added new definitions that made them all parallel. Through
I
that
haven't done
deductive
that.
logic.
I didn't do that.
Yeah, that's exactly what you did. Anyway,
No,
I got to go.
it's all
See you
right.
later.
I didn't make them like that. Look, I'll go over with everybody just so that you can hear this. 1, straight lines are not circles. Circles are not straight lines. 2, horizontal is a straight line on a vertical plane. 3, vertical is a straight line perpendicular to a horizontal plane. All horizontals are parallel, planes or lines. All perpendiculars to a horizontal plane will be parallel. Plumb and level are perpendicular. And vertical and horizontal are perpendicular. And then there's a mathematical proof there. Thank you very much, Sarakaki. Proof of perpendicularity through mathematics. Anybody who disagree with any of those statements, say thank you to Rams for bringing that up. He got triggered by these statements from reality as to say that they can't exist in reality. Okay, I'm going to just end this stream and I'm going to come right back on the other one. So I have